Stoichiometry can be one of the easiest topics that you encounter in chemistry. When performing stoichiometric calculations, simply write a balanced equation. From that balanced equation, write a molar ratio. And from the molar ratio, create a fraction. This fraction is then used to multiply times the given moles or the calculated moles of a substance to determine the moles of another substance in that balanced equation. Hi, Mr. B here. In this video, I will explain the easy way to perform stoichiometric calculations.
System alert.
The concepts of mass, mass mole, and mass particle stoichiometry may be summed up in the following practice problem. What mass of precipitate will form when 30 grams of sodium carbonate reacts with excess cupric chloride? And the problem goes on to ask how many molecules of precipitate are formed. The first step in solving any stoichiometry problem is to write a balanced chemical equation. Sodium carbonate, Na2CO3, reacts with excess cupric chloride, CuCl2. When a compound reacts with another compound, the type of reaction will be a double replacement reaction. In a double replacement reaction, the first elements in the formula will exchange partners. So as a product, sodium chloride is produced and copper 2 carbonate is also produced. Cupric, the IC ending for the copper, indicates that copper will have its higher oxidation state in this formula. Remember, on the periodic table, copper ions may possess a +1 or a +2 oxidation number. The IC ending indicates that in this compound, copper will possess a +2 or 2+ charge, which is why the formula is CuCl2. When halogens react or combine with metals, the ion will always have a -1 charge. -1 + 2 does not cancel out or equal 0. Therefore, after crisscrossing, the formula will be CuCl2. It is also appropriate to write in the states of matter. Compounds containing group 1 ions are always soluble. So, sodium carbonate, it will be in the aqueous state. Copper 2 chloride. Ions of halogens are also soluble with a few exceptions. Copper is not one of those exceptions. In other words, copper 2 chloride will indeed be soluble. Sodium, a group 1 ion, will form a compound that is soluble. Carbonates are generally insoluble with a few exceptions. However, copper is not one of those exceptions. So this compound, copper 2 carbonate, will be insoluble, so we write the state of matter as a solid. In fact, during this reaction, copper 2 carbonate will precipitate from the solution. Double replacement reactions are also known as precipitation reactions because during a double replacement reaction involving compounds, generally a precipitate will form. Now let's balance the equation. 2 sodiums, 1 sodium. So clearly our first step should be to place a 2 in front of the sodium chloride. Carbonates, polyatomic ions, are generally balanced as a unit. Here we have 1 carbonate, so the carbonates are balanced. 1 copper, the coppers are balanced. 2 chlorides and 2 chlorides. So the chlorides are also balanced. In the case of sodium chloride, the chloride was balanced by placing a coefficient 2 in front of the entire compound. Coefficients will apply to each element following it in the formula. So we've just written, or this represents, the balanced chemical equation for a reaction where sodium carbonate reacts with copper 2 chloride to produce sodium chloride, and the precipitate copper 2 carbonate. The next step in the process is to write a molar ratio. The molar ratio is simply the numbers that exist in front of the formulas in the balanced equation. In other words, the molar ratio represents the coefficients in the balanced equation. If there is no number written in front of a formula, then the number is assumed to be 1. The molar ratio for this equation will be 1, 1, 2, 1. The molar ratio is now used to create a fraction. In a balanced chemical equation, the molar ratio must be maintained. Since we're given information about the sodium carbonate and asked information about the copper 2 carbonate, then the ratio of sodium carbonate to copper 2 carbonate must be maintained. The problem is we're given 50 grams of the sodium carbonate. A molar ratio requires that the given mass be converted to moles. To do so, simply use the mole calculation, where moles are equal to the mass divided by the molar mass, or gram formula mass. So we have 30 grams divided by 106 grams per mole. Divided by 106 grams per mole is equal to 0.28 mole. Now we use the molar ratio to determine the moles of the precipitate. Since we are unsure about the moles of the copper 2 carbonate, and now we know the moles of the sodium carbonate, the fraction will be 1 over 1. In general, when creating a fraction, it will be the coefficient of the unknown substance, in this case copper 2 carbonate, so we'll just write an X here because it is unknown, divided by the coefficient of the known substance. In this case, the known substance is the sodium carbonate, so let's place a check over that number. And in the fraction will always be X over check. So the 1 for the copper 2 carbonate is in the numerator, and the 1 for the sodium carbonate is in the denominator. Clearly, in this particular case, it is irrelevant since both numbers are 1s. 0.28 times 1 is equal to 0.28 mole. To determine the mass of the precipitate, simply use the mole calculation, where moles are equal to mass divided by the gram formula mass. In this case, the unknown is mass. So solving for mass, we get mass is equal to moles times GFN. The moles were determined to be 0.28. The molar mass of copper 2 carbonate is 124 grams. So 0.28 grams times 124 grams per mole are equal to 34.72 grams. So the mass of the precipitate will be 34.72 grams. The second part of the practice problem asks for how many molecules of precipitate. Since we know that the precipitate is the cupric carbonate, then we can use the moles determined for this compound to determine the number of molecules. We also must use Avogadro's number. According to Avogadro, the number of molecules are equal to Avogadro's number, 6.022 times 10 to the 23 molecules per mole. Now simply multiply Avogadro's number times the number of moles of the compound, 0.28 mole times Avogadro's number. Multiplying the number of moles, which is 0.28 mole, times Avogadro's number, 6.022 times 10 to the 23 molecules per mole, will equal 1.69 times 10 to the 23 molecules. So the number of molecules of precipitate formed will be 1.69 times 10 to the 23 molecules. Okay. Now you should have a better understanding of mole mass and mole particle stoichiometry. Mr. B here. Catch you on my next video. Have a great day. See ya.
Exiting the system. Affirmative. Goodbye.